Joining us is Wayne Hoyle. He is a senior director with MDA, and he's going to be talking to us about something interesting called Chorus. Hi, Wayne.
Good afternoon, and thank you for having us.
No problem. Always a pleasure to be working with MDA and having you here at GeoIgnite, Canada's National Geospatial Conference.
So what I'm going to do is talk to you a little bit about the next SAR mission that we're building at MDA called Chorus, and explain a little bit about how it's going to change how and when we change the world or see the world. Part of it initially is going to talk a little bit about the details of the mission itself. Talk about some of the heritage it's based on, and the video that we just saw was showing some of the RCM prior to that, RADARSAT 1 and RADARSAT 2 operational. So talk a bit about the heritage, talking about some of the imaging modes. Exactly, it's an imaging satellite, so some of the imaging modes and how are those going to help. And then I'm going to go through a couple of different use cases that show some of the advancements that are going to be coming as a result of this. One of them is a maritime cross-queue, where we're basically going to be showing how we can cross-queue from one of the satellites to the one that's trailing it. And then two other areas of interest, very, very relevant from the presentation we just saw, initially looking at the Canadian agriculture area and how coverage will be improved with that. And the next one, really looking at some icebergs in the North Atlantic. And then as you mentioned, hopefully having some time for some questions at the end. So the big question really, what is Chorus? And Chorus is a synthetic aperture radar mission, MDA's new synthetic aperture radar mission. It's built based on the prior RADARSAT 2 mission. So it's going to be our 4th generation C-band satellite, providing RADARSAT 2 data continuity with enhanced capabilities for our existing and our new customers. And I'm assuming that a lot of the folks that are dialed in for this conference are very familiar with the RADARSAT 2 and the RCM products that are being produced on a daily basis. One of the key differences that we're going to see with Chorus is it is not just a C-band SAR satellite, but it also has a trailing X-band satellite, and it's going to be operating in an inclined orbit. And I'll explain a bit more about that later on. It's designed to allow us to have the very broad area coverage, and also higher resolution spotlight data, and very specific for some near real-time applications. It's going to operate in a low Earth orbit, very much like the same altitude as RCM, but it's going to be on an inclined orbit, which means that it's going to see the world between 62.5 degrees north and 62.5 degrees south. It doesn't cover the poles. A number of enhancements with regards to imaging that's going to give us the higher and broader coverage, higher resolution, lower noise, less data compression, etc. We'll talk about that later. And unlike other RADARSAT missions, most of our sun-sync satellites image at 6 a.m. or 6 p.m. for SAR. Chorus is going to be changing the time that it flies over a particular area by about 20 minutes every day. So it's going to be getting 20 minutes earlier each day, which is really going to help to show how we're going to change when we see the world. Key to the design is having a capability to do fast tasking and downlink, near real-time downlink. So we will be able to task the satellite very dynamically and then downlink the data to a headquarters station or one of the many network stations globally. And with that is the exploitation of that data and the ability to then provide follow-up actions with the trailing satellite or cross-queue, and I'll talk about that. The C-band satellite will have about 20 minutes worth of imaging capacity, and the trailing X-band satellite will have 3 minutes. So a combined of 23, which is significant. It's adequate to do a number of missions, including some systematic collection things such as agriculture or forestry or mining type applications, as well as the more dynamic things that need that data in real time, near real time. And to be able to make some of the cross-queue capabilities actually operate, we're going to need to be spending a significant amount of effort in development and introduction of some machine learning and AI that's going to help us to go from a C-band to an X-band within the time frame. The graphic that I'm showing here has got the C-band up at the top and then the X-band down at the bottom. And the X-band is going to be following the exact ground track as the C-band. talking a little bit about the CHORUS heritage, and really what I'm saying here is it shares an awful lot of the RADARSAT DNA. As I mentioned before, this is our 4th generation satellite. As you can see from the top row here, the mass of the satellite is going to be about 2,200 kilograms. So it's a very large satellite, about 50% bigger than RCM, about the same size as RADARSAT 2. The biggest swath width, for CHORUS, is going to be 700 kilometers. I'll talk a little bit more about that, but it's very, very broad imaging capabilities. Its altitude is going to be the same as RCM, around 600 kilometers above the Earth. But the orbital inclination, instead of it being the 98 for RADARSAT 2 or the 97 for RCM, it's going to be at 53 degrees. And I'll show why and what that impact is. Already mentioned about the time of day that it images being changing throughout the cycle. The data cycle that it goes through is going to be a 10-day, or roughly a 10-day cycle, 9.85 to be exact cycle, where we'll have an exact repeat every 9.85 days. This SAR antenna, the main antenna for reception of data, is about double the size of that of the RCM. And we have a dual aperture working with that. Because the satellite flies in and out of the sun every single day, every single orbit, it's going to be going in and out of the sun. The solar panels and the power generation capability and the batteries need to be significantly upgraded. So you'll see that we have a 5,700 watt capability for this power generation compared to RCM of being 1,600. And then the solar arrays are about 5 times or more than 5 times the size. The satellite will be able to look both left and right in either a left or a right looking mode. Same as what RADARSAT 2 was able to do. And we anticipate that we will be required to slew the spacecraft many, many times throughout the day. From a data collection perspective, the polarization is going to come in single pole or cross pole, but also the compact pole, which was introduced with RCM. So we're pulling that across and going to include that. One of the key attributes that we have with RADARSAT 2 is that we have a priority-based ordering where customers can specify the exact location that they're looking for and when they want that image to be collected. We can lock that in and guarantee that delivery. That's going to be carried forward with CHORUS. So it's going to be a first come, first serve priority-based ordering. And then on the delivery and tasking timeline, significant improvements as it relates to the tasking timeline. Less than 1 hour, we're going to be able to accept orders and task the satellite. We're going to be able to do change detection. The speed and downlink of the data is going to be vastly improved. And the downlink can happen at our headquarters systems here in Canada. It could, data can come down through the regional ground stations that we currently have with RADARSAT 2, and we'll be talking about doing upgrades to those, or through cloud-based capabilities. The other side of it, and I've sort of separated it out a little bit, is the X-band. And the X-band, as you'll notice, I'll just sort of go over a couple of things here. Number one is it's a small sat. It's 115 kilograms, or more or less 100 kilograms. It will give us a maximum swath width of 100 kilometers, and will operate in the exact same orbit as what we're doing, but a much smaller satellite with very, very high resolution capability. So from our perspective, what we're really doing is we're pulling together the best of prior RADARSAT 2 missions with a lot of innovation and bringing in some small sat capabilities. From what is the imaging modes? This is sort of a beam mode diagram for those that have seen them with RADARSAT 2. At the very top here, we've got the 140 kilometer, the 700 kilometer swath. It says here 140 kilometers. We're currently going through the design for CHORUS. This is a document that was prepared back at a little while ago at PDR. We now have, this is going to be 100 meters at 700 kilometers or 50 meter resolution at 700 kilometers. So we're making some refinements, some improvements on the capability. But we have the broadest area, 700 kilometers, let's say a 50 meter single look. We have a number of vessel detection modes that are going to be available. We've got a number of strip map, 8 meter, 5 meter strip map modes, and spotlight. CHORUS C is being designed, built, owned, and operated by MDA. And it will be complemented with an X-band satellite. The X-band satellite is is based on the ICEYE out of Finland, their Generation 3 satellite, but will be modified to operate in our orbit. And MDA will have 100% utilization and capacity tasking of that. What it brings to the picture is really a 100-kilometer swath scan mode, which it's not shown on this diagram. It also brings in strip map, and it brings in the 1 meter spotlight, the 1x1 spotlight, which is something we are not able to achieve with the C-band. So very excited to be able to have that capability. To try to show the audience here what are the products going to look like when they're actually available to you. One of our folks, Ron Caves, has gone into the archive from the CCMEO and pulled out a compact pole, 5-meter compact pole data from RCM over top of Vancouver, and used some techniques to colorize that. And very interestingly, you can see significant details both in the water and the land, some of the agriculture areas here. This is what we're going to have with the compact pole for all of the CHORUS images, or for most of the CHORUS imagery. As we zoom into Vancouver area here, you can see very high density, very high returns. So you kind of lose some of the fidelity there. This is where the X-band is going to come in, where we're able to take a 1 meter resolution. For those that know Vancouver, this is the BC Place Stadium. You can see the high-rise buildings, etc. So this is what we're bringing forward with CHORUS, is the ability to have these very large areas in compact pole. It's going to give us the bigger picture all the way down to very high resolution spotlight. At the other sort of end of the spectrum, that was sort of zoomed in quite a bit to Vancouver, we have the ability, because of a 700-kilometer swath, which is what I'm showing here, is to do what we're saying really countrywide coverage. We're covering off almost the entire city of France, the entire country of France within a single pass, unprecedented by SAR data. We can then zoom in with a 3-meter product here that we collected on December 9th. This is over the city of Paris, and then zoom in further with a 5-kilometer spotlight image at 1 meter resolution. So we can go from country, so the broadest area, down to the highest resolution with CHORUS. To try to show how the two satellites can work together, I'm just doing a little bit of a illustration here off the West Coast. So this is sort of the West Coast area of interest, where we may be using the iStop program or some program to detect illegal vessels or illegal oil dumping. And on this particular date, we were showing the satellite flying over top at 2219. This was on February 21st, so last week on 2219. Satellite's going to collect the imagery in real time, downlink the imagery to the ground station. It's then going to run some vessel detection algorithms to find vessels that are not correlated with the AIS. It may find some evidence of oil on water, and it may find some other vessels that are correlated with the AIS, all done in less than 15-minute period. So this was at 2219. About 55 minutes later, the X-band satellite is going to come into field of view. And we would then be uplinking the coordinates of the location of where we're looking at the vessel and the oil. Satellite then progresses an hour later, so 60 minutes after that first collection. It's now over top of the area that we're interested in. It's going to image. It will also downlink to the ground station and provide a high resolution image of the vessel of interest, having detected it and projected where would it be in 1 hour, and also a higher resolution image of the oil that we thought we had detected in that first image. So basically closing the loop on that from the first detection with C-band through to the cross queue, and ultimately to having the higher resolution data available within about an hour and a half from that first detect. So very, very fast tasking for near real-time applications. Many applications that would be using this on the maritime and land intelligence side. Shifting a little bit to the orbits that we've selected and talking about the advantage of the inclined orbit. What I'm showing here is the ground track, the accessible swath that we're going to have for CHORUS. And this is in a left-looking mode. So everything in red is left-looking. And what it's basically saying is we get a lot of Canada up to the middle of Hudson's Bay. But we don't go all the way to the north. So we go up as high as 62.5 degrees. If we're in a right looking mode, we can see down almost to Antarctica, but only up to sort of the middle of Canada there. And so in the right looking mode, we get the southern part. In the left looking mode, we get the northern part. And we anticipate that we're probably going to be switching directions, the look direction, slewing the satellite, probably 15 to 20 times per day to achieve the maximum coverage for our customers. In contrast, this is what a typical sun-sync orbit or polar orbiting satellite will look like. And what we look at is these size of these gaps where we don't have access in any particular day compared to these ones. So what we call the black diamonds, where we don't actually have access. So it gives us much greater imaging capacity within a single day period. And when we combined it with the left or right, it just gives us much, much greater revisits. The next few slides I'm going to walk through is just to say, how does that actually apply to the Canadian area of interest? And as I mentioned, CORUS can only see as high as 62.5. I recognize there's a lot of interest in ice monitoring and permafrost north of 62.5. But there's RCM that are orbiting up there. There's other satellite capabilities, polar orbiters. So we're going to focus on the area below that. I've drawn a polygon here, which you'll see in red. That is what I call the extent of the Canadian core area of interest. It includes the maritime areas. It includes the majority of the landmass, and then sort of dips down a few areas where we have interest in some flooding or in the Great Lakes here. Overall, 11.5 million square kilometers, very, very large area. I did a simulation. We did a simulation of this from February 1st, starting at 0 Zulu. And the satellite was starting here at 0 Zulu, the satellite will go from west to east. It actually probably started over here at 11 or 23:55, but anyhow, we started here. And so it's got a 4-minute and 23-second pass coming across on its first pass of February. This one was at 0. About 100 minutes later, it started up here in Alaska and came down through to the Great Lakes, about a 10-minute and 44-second pass. Then another 100 minutes is another descending pass that is going to be coming down the west coast. And the area of this, each of these swaths is 700 kilometers, which is equal to the greatest or the broadest collection we can do. Pass number 4 is actually an ascending pass coming up the eastern seaboard. Then we move west with the next pass here, pass number 5 at 1724, pass number 6 at 1922, pass number 7, almost going from completely across the country, a 15-minute and 58-second, so almost a 16-minute pass, pass number 7. And the last one of the day here, pass number 8, is again almost 16 minutes at 22:19 Zulu. So overall, what we have done in a single day was 91% of that 11.5 square kilometers was collected in a unique way. In many cases, as you'll see, there is double collections, so we're able to do more than that. But it's a phenomenal coverage. I then went through and said, well, was that an anomaly? Did I pick a day that was just particularly good? And the answer is no, that the February 21st that I'm showing is actually the worst of the days that in the 10-day cycle. And the average is actually 92.6. So from a CORUS perspective, we'll be able to cover up 92.6% on average of that core area of interest, which is something that it cannot be done by polar orbiting satellites. To sort of illustrate that, I did the same simulation with RADARSAT 2. And RADARSAT 2's broadest beam mode is 500 kilometers, which is what I'm showing here in blue. And because it's polar, it sort of goes, a lot of the orbits just go north-south. RADARSAT 2 is still one of the best imaging satellites from a SAR perspective that is available, but it can do 51.5% on February 21st, but on average it was 48.8. So a significant difference in what we can do in coverage across those two. Interesting again with Catherine's presentation earlier. I grabbed one of the numbers from there that $61 billion worth of exports comes from the green area that we're showing here, the agriculture area. And SAR data is used to help to monitor that. We tried to capture that in a polygon here. The area is 1.8 million square kilometers in the green. And if we were to use RADARSAT 2 data, the traditional mode that is being used is a 8-meter imaging mode, which is wide fine. These orange boxes here are scenes that we would be able to collect on February 21st. And it shows that we'd be able to do 18% of the area of interest in a single day with RADARSAT 2. Now, to contrast, using CHORUS, the C-band CHORUS, these green boxes are showing what we could do. We're able to collect 51% of that area in a single day. And again, you'll see there's a lot of areas where we're doing double collections, collecting twice in a day. So we're able to do 2.8 times the coverage of what RADARSAT 2 could do with CHORUS. And this is an example, again, from the CCMEO site of an RCM data, which has been colorized. You can see down here, it's in Abbotsford. You can see down here, here's the airport, the highway coming through, some mountainous areas, and very, very good delineation of crops, and then the Fraser River and bridges. So very, very good and much easier to interpret than the traditional black and white imagery that we have from single pole or dual pole satellites. The second example I'm sort of walk through is the North American Ice Service. And their job really is to track with ships, aircrafts, and satellites where are all the icebergs in the North Atlantic, trying to prevent collisions with icebergs and damage to vessels. What's produced is a map that looks like this, where it has the magenta line that says this is the southern extent of icebergs. Stay south of here, you should be safe. And it's done by both the Canadian Ice Service and the US equivalent of that out of the US are doing it in collaboration together. What I've done is a simulation pulled off from February 22nd, I think it was, pulled off the southern extent of the ice, and then said, well, let's look at a 300-kilometer boundary around the outside of that. And in this case, it came to 625 square kilometers. What we're looking for is big icebergs that are going to be causing damage. If we were doing it with RADARSAT 2, again, a polar orbiting satellite, the satellites cross very, very up and down, very vertically through those areas. And if we then say, well, what is the coverage we could do? Again, trying to use a beam mode that's going to detect those small small icebergs, it will provide us with about 23% coverage on this particular day. Actually, this is from March 2nd, I'm sorry. So that was from today. So we would be able to cover about 23% of this area for today. Consequently, to a large degree, the way that the surveillance is done right now is a lot of aircraft and some use of satellites, whether it's RADARSAT 2 or Sentinel or whether it's RCM. This is sort of the way that is being used now. With CHORUS, we think that things can change. And this is the coverage that we would have with CHORUS. We'd be able to do 63% of that same area on that particular day with the C-band, or 2.7 times that of RADARSAT. Of RADARSAT, yes. So we're going to be able to take and say, perhaps it could be pivoted where satellites become the primary and ships or aircraft become secondary for this use case. As far as the iceberg detection, this is sort of some trends that I pulled off of the latest report from the National Ice Service in the US, from NAVCEN. And it shows the percentage of icebergs that they have been tracking and how that has changed over the years. In 2016, none of the icebergs were detected using satellites. And in 2020, I think this is partially pandemic related and limited flight hours, but over almost 80% of the icebergs were detected through satellite means. In this current year, they had 410 satellite images that they used, Sentinel-1, Sentinel-2, and RCM, and we're able to detect about 2,000 icebergs in that period. And what I think will happen and can happen is that a far more efficient ice tracking capability could be developed, where you're much less reliant on ships and aircraft and much more reliant on a more efficient satellite-based capabilities. So it's a bit of a whirlwind sort of through the capabilities of what we're talking about, but in conclusion, CHORUS offers significant improvements over the RADARSAT 2 and RCM. Plus, it has the trailing X-band. Will provide you with very large scene size, up to the 700 kilometers, with lower noise, less compression, higher resolution, and very much geared towards the near real-time operations with cross-view. That's really going to help to show, change how we see the world. And then from a coverage perspective, because of the orbit, we are going to be seeing that the area that we're interested in here in Canada and other parts of the world much more frequently than you would with a traditional sun-sync or polar orbiting satellite, giving you better coverage in the Canadian AOI or specifically for the agriculture Iceberg examples that I showed. For the number of years, Canada has been a significant pioneer in the use and exploitation of SAR data. We fully expect that CHORUS is going to enable some new use cases, a number of new use cases that's going to allow us to sort of push that forward. And we look forward to engaging with the members that are here on understanding what their end user needs are, departmental needs, and how can CHORUS fit into that going forward.
Great presentation. That's the first time I've had a chance to see what CHORUS is. And the burning question I have is, how did you guys come up with the name?
So the name is and I should have mentioned that the name, because we are looking at different frequencies working together very, very tightly. So the C-band and the X-band working together, we're going to be pulling in, as time goes on, other capabilities. And so this is going to, CHORUS is currently, we're looking at the SAR. But to actually close off some of the mission requirements, we're going to be pulling in AIS data. We may be pulling in some ELINT data. And so it's going to have a number of different satellites working together as one. And so really the CHORUS side of it. It is going to be a significant development over a number of years for MDA, but this is the first part.
Thank you. I see we've got a RADARSAT veteran in the audience asking a question. Shout out to Vern. Vern's asking, Wayne, talk to us about dual frequency INSAR.
Okay. I think dual frequency, meaning can we do INSAR between the C-band and the X-band? I think the answer is no. I don't believe that's going to be possible. We will be able to do INSAR based on the C-band, C to C, or we will be able to do INSAR from X to X. But I do not believe it's possible to do INSAR between C and X. I don't know if that answers your question, Vern.
Thanks for that. Can you share a little bit more about the projected timeline for this?
Sure. I can share what I can tell you, and I guess the first thing is that MDA started this, and I was fortunate to be invited to be part of this program very early on when just at the beginning of the pandemic, so almost 2 years ago. So it was a small group that we started off with a couple of years ago, working through some of the concepts and whatever else. We're now at a team of about 300 people working on this. So we've got folks throughout the country, both within MDA and contractors. We have completed the mission PDR last year. We are working towards the mission CDR later on this year. And once we have achieved mission CDR, we'll have a better idea of exactly what the launch date is, and we'll advertise that. But significant progress, very, very big program. I think RCM took about 11 years from the time we started till the time it was launched. It's going to be significantly less than that. But we will not be announcing an actual launch date until after we complete the mission CDR later this year.
Fantastic. Yeah, we've got quite a few questions coming in now. Will there be a single C-band CHORUS satellite, or are you planning to launch more over time?
Excellent question. I think that the concept of CHORUS is that we are going to be developing that constellation as there is demand. And so the initial one is what we're talking about here. I think there is a need, and there will be a need for some increased coverage over the poles for some of the folks on the line. Fully aware that we have RADARSAT 2 and 3 RCMs, and we've got the Sentinel satellite, and there's an abundance right now of polar coverage. But as time goes on, we think there's going to be a need for a polar version of this, or maybe a couple of them. But that will be sometime down the road.
Great. Another question, in terms of coverage, you mentioned better frequency than RADARSAT 2 and RCM. Well, yes, but can you speak to the Arctic coverage? That's not the point of CHORUS, I think.
Exactly right. I think the analysis that we did, and it really goes back to, we have fantastic coverage of the Arctic with the 3 RCMs. They do a fantastic job up there. And then you layer on top of that the Sentinel 1A, I guess now, 1B is no longer operational. But the Sentinel birds are up there providing great coverage. And most of the other SAR satellites are polar orbiting. They fly over there 14, 15 times a day. And so we've chosen to say, we don't need to go up there. It's very crowded. There's tremendous coverage. Let's go to where there is a need, which is in the mid latitudes.
An anonymous question from John Rose. What is the lifespan of the X and C band birds? Great to hear about CHORUS.
Yeah, the mission life overall and mission design is 15 years. And so we are designing the CHORUS C-band satellite for a 15-year mission, and we will probably have a number of X-band launches required to work through that same period. It will not have a 15-year life on the X-band, but there will be a number of launches to sustain that.
Thanks. So I think that concludes. We're already into our break. I wanted you to give you a chance to talk a little bit about your workshop that's coming up March 11th.
Yes, excellent. Thank you. Yes, on March 11th, we have a workshop that is going to focus on some of the key capabilities and benefits of the different SAR frequencies, primarily the C-band SAR, which would be the same as the RADARSAT 2 or RCM or CHORUS, the X-band, which is the CHORUS X or the ICEYE, as well as some of the others, and also the L-band. And we're going to have some experts on each of those being able to talk through a workshop over, I think it's a 4-hour period. So please, if you're interested in that, please dial in. It won't focus on CHORUS. It's just going to be talking about the science of the actual capabilities. But please dial in for that, and happy to have you contribute.